Okay, ladies and gentlemen, having achieved triumph over the adversity, we continue. So here's one way. We have a mortality rate and it goes off on a fixed event. But suppose, ladies and gentlemen, we don't want that. Suppose we want to have mortality that's endogenously dynamic. That is, people at different smoking states have different mortality rates, right? How could I capture that? How could I capture that? How could I have a mortality rate that changes over time? What would that need to be? A parameter?
Dynamic event.
Okay. Dynamic. There's going to be events that could be involved. But suppose I have something. Right now, there's a parameter mortality rate that lives in Maine that directs this mortality. What do I need instead of a parameter? A variable. I'm going to have a variable. Okay. Now, this variable, where have we seen a variable that? So we want a variable where the mortality rate will change depending on what state we're in. Where have we had a variable that changes based on what state we're in before? It hasn't been a very deep one. It's not one that has great data implications, but it was important for the user interface. What variable changes every time we change state? Color. We could use a similar variable strategy so that every time they change state, their mortality rate changes. What do you think about that idea? Are you okay with that? Let us bend ourselves to that task. Okay? Okay, ladies and gentlemen. Drag in variable. And we will set this to be mortality rate. Boom. But let us go remove the mortality rate from Maine. Okay, we've eliminated it from Maine. There we go. Okay, mortality rate here is initially we're going to set it to 0.0. Okay, and we will set it to be a different value for each of never smoker, current smoker, and former smoker. Are you ready for this? Okay, I'm going to show you several ways to do this. Okay, so in never smoker, what do we need to do if we want to set that to a certain value? What do we need to write? Mortality rate, what? Equals, and let's make it 0.01. Okay? On average, they live 100 years. Well, that's a little bit high. On average, they live 0.015 years. Okay? Oh, sorry. On average, they live 1 over 0.015 years, which is somewhere around just short of 70 years. Okay? Okay, next. Current smoker, we'll have them leave mortality rate being 0.03. Maybe that's a little bit high, 0.025. 0.03 would imply an average number of years lived while a current smoker of 33 years. 33.3. It's 1 over 0.03 is the average amount of time until mortality. So we'll do that. And then former smoker here, ladies and gentlemen. Former smoker, we will put it somewhere in between these. In between 0.025 and 0.015. We'll make it 0.02. This is a sort of parameter that we might get from data. And if we were building this model at a realistic level, we wouldn't put these hard-coded. What we'd instead put is a parameter in Maine or we would put in place what's called a constant variable, static constant variable that would encode those values. But for now, and as a pragmatic matter, I'm going to place this here. Okay? So that's step one. The second thing I'm going to do is to go to mortality and have this, instead of depending on main.mortality rate, which no longer exists, have it depend instead on what? It's not the mortality rate of the main, nor of the Spanish main, but it's a mortality rate that lives here. So we just say mortality rate. It's this variable mortality rate. Do you see that? Ladies and gentlemen, let's build the model. Oh, look at that. It's an unhappy camper. Okay. Oh, yes, I did something bad. Okay, I should have built that earlier. Okay, initial age cannot be resolved. Okay, hopefully you don't have this issue. Current age. Oh yeah, I forgot to update that. Okay. Fine. So this is birth time. So time minus birth time. That's what we need there. Birth time. Boom. Okay, there we go. Boom. Done. You ready with that? Ladies and gentlemen. Ladies and gentlemen. Let us now, so we just set this mortality rate to depend on this. Now, there's a question in my mind here that about which we need to be cautious. Okay? The question is, are people dying properly here? I actually don't see evidence of it, and there's a reason for my concern. Circumstantially, it seems they are. May I show you a way to tell if they're dying? This is a very key thing for debugging. That sounds overplayed, but it's actually really true. It's a very key thing. I use those words advisedly. How would I tell if people are dying? Well, I could actually go and I could say trace ln so I could say this plus died. And what that will actually say is the person's name and the fact that they died. But we'll have to put it before this removed population, so they're still around. Okay? This died, meaning it'll print out their name saying that they died. Are we ready to see this? If they are dying, what should we see? Lots of those things appearing. Shall we try? This is in the mortality event. We say trace ln, this plus, and then in quotes, died. Are we okay with that? Ladies and gentlemen, who needs TA help? Okay. Look what's occurring behind me. Do you see this? It's telling me that people are dying. People are dying. And the smokers are dying quicker than others. Why are they dying quicker than others? Well, the mortality rate associated with them is actually higher. Okay? Now I'm gonna test something. I'll tell you why I'm testing it here. I want to make sure I'm in no way misinforming you. I'm going to set it so they have mortality of 0 if they remain a never smoker here. Okay? And still people are dying. It is clear that as they are reaching the smoker state, their mortality rate is being reconsidered. And it is applying to this mortality event. And Winchell can take note of that. Yeah. Ladies and gentlemen, we have to be cautious here because sometimes any logic isn't smart enough to take into account a new value of things. Here, mortality needs to realize, oh, there's a changed value for this person's mortality rate whenever it changes. Fortunately, because when we change states, it automatically reconsiders this. That actually works. And so here they are dying at higher rates when they are current and former smokers. Okay? We've achieved differential mortality by this. Now we could have, alternatively, we could elaborate this. I like the way this is going, and I will pursue it. Ladies and gentlemen, now suppose we want a mortality not just affected by smoking status, but by age. Perhaps we wish not to hard code a mortality rate for each of these, but rather we're specifying a hazard rate ratio for each of these. A multiplier by the baseline hazard rate by age that takes into account their smoking status, as might emerge from a survival analysis, for example. So perhaps what we want is not to hard code never smokers have a mortality rate of X, but rather never smokers have a reference mortality rate. They have the baseline, and current smokers have twice that, and former smokers have 1.5 times that, as might emerge from analysis. So we'll have a baseline hazard that's given by age, and then a hazard rate ratio associated with this, or you can think of it as kind of an incident, a relative incidence rate. So an incident rate ratio was associated with their smoking status. So with your leave, what I will do now is I will post this model. I will save it here in case anyone wishes to obtain it. It'll be version 4, and I will place it up on the site. Here we go. It rests even now on the site. Okay, ladies and gentlemen. How would we capture a hazard rate for mortality that varies by age? Have we ever done something like that before?
The distribution?
Sorry?
Distribution.
Yeah, we'll specify
Function type.
a function that specifies a set of hazards by age. And we in fact did this before. Do you remember? This initiation hazard, do you remember that? We specified it's a table function, ladies and gentlemen, okay? So here we will specify a hazard rate that changes by age. Now we could do it with a table function, and that would be suitable for empirical data. We could also do it in a parametric way. We could do it with in a way that might emerge from a survival analysis with a characterization of some baseline hazard times exp beta 0 plus beta 1 times smoking status or beta 2 times age or what have you. Here, what I'm going to do is I think what I'll do is to make use of one. I'm thinking sort of the next steps and the warnings I want to give. I think I'll do one with a table function. I think that's easy enough to carry out. There's kind of this collinearity between age here and time, that one's been in a state here that's a little bit tricky. Okay, so here we're going to introduce a table function. There we go. And this will be mortality. This will be baseline mortality hazard by age, okay? There we go. And here we are going to have for the youngest years, we're going to have 0. I'll make this simple. 0.01, maybe 0.005. By age 5 here, we'll make it 0.001. Youngest years have some risks associated with them. We'll make it 0.001 still for 10, year 10. In the teenage years, it will go up to 0.003. By 20, it will go up to 0.002. And then 25, 0. That's probably downplaying that, but in any case, 0.002 again, 30. I'll start doing it by course or age categories now. 0.003, and 45 we'll do 0.01. Starting to see the impacts of some behavioral risk factors. 55, 0.02. 60, those are probably underplayed. 0.03 for 55. 65, we'll do 0.05. Maybe 0.010. Yeah. Oops. And 75, we'll do 0.15. Yeah. Put this down. Okay, there we go. And 85, we'll do 0.02. And 90 plus, we'll do 0.04. Okay, fine. Okay, and here we will set this to be out of range. If we get a value outside of that range, we'll use the nearest value. So if we get someone who's more than 90, we'll use this value. Okay. Notice we can load it from a database, incidentally, and we'll come to databases soon enough. Okay, here we go. So this is a rising hazard rate by age. Okay, it specifies how the hazard rate rises by age. Next, for the mortality hazard, we're going to want to take into account the age of the person plus take into account the hazard rate ratio associated with smoking. So rather than hard coding mortality rate, I'm going to have mortality hazard rate ratio. For smoking. If not descriptive. There we go. Hey, come on. Don't give me that. Okay. And for never smoker, the mortality hazard rate ratio for smoker will be 1.0. There's the reference category, 1.0. And for a current smoker, the hazard rate ratio will be, say, 4.0. They're going to have a much higher chance of mortality. And hazard rate ratio for smoking associated with former smoker will be 2. We could have that change over time as the degree of the length of time since they smoked changed, or based on their smoking history. And then finally, we're going to need to have the the mortality rate be calculated based on both of those. Okay? Now, we have to be careful here, because this mortality rate will be calculated every time they switch states here, but it's not going to be calculated every year. So, the way to do this is to move beyond handling it with an event. It's the simplest way. I'm going to get rid of that event, and I'm going to put in place a different mechanism that is commonly used in the circumstance. And this is going to be mortality state chart. And this is going to present a stark view of life, where someone is either alive or they are going to move to a final state. They're either alive or they experience death and they move to a final state. The reason I'm switching is it's hard with an event to tell it to wake up and recalculate it. We could do that. Thank you so much. We could do this much more readily here. Okay? We've done it before. Right there. We'll do it again. Here we go. Ladies and gentlemen, at this mortality event, we will remove the person from the population. So main.remove underbar population of this. Just like that. This is what was in the event before. The deal is what's going to be here. So this is the same thing we had before. Main.remove population of this. Okay? But, ladies and gentlemen, the trick is going to be what lies here. And what's going to lie here is going to be the following. This is going to be set to a rate. And the rate will be given by what two things? Anyone know where I'm heading here? What? Based on their... Yeah. It's based on mortality hazard times what? Yeah. Okay. So it's going to be this baseline mortality hazard for their current age. So baseline mortality, okay, it's not filling this in, okay. It's being truculent, as it occasionally does. Baseline mortality hazard by age. And that's going to be a function of my current age. So we're going to look up my current age. And then we're going to multiply it by what? The mortality hazard rate ratio for my smoking status, ladies and gentlemen. We'll multiply this up front by mortality hazard rate ratio for smoking status. I believe Winchell and likely Annie will have encountered these occasions where any logic does not perform autocomplete under certain circumstances. True or not? Yeah, and it's a blemish upon the software project. Okay, ladies and gentlemen, let me rehearse, because I know I just did something that was fairly involved. I'd like to rehearse what's going on here. We're not yet quite done. Maybe we'll do one final thing. This is what we'll do. See this item here? We will copy that, and we will go paste a copy of it over here. Okay? We'll go, here we are, paste it, move it into docking position. It is docked. Okay, there it is. How did I do that? Why did I do that? Let me retrace the steps. Okay. I'd like you to follow my thinking here. Why did I do it this way? I did it this way for a very specific reason. We had a nice event, which calculated mortality rates. That event handled the case where we wanted mortality to depend on what state they were on. Because it's automatically recalculated, it turns out, when they change state. but it's not automatically recalculated when they change age. They're changing age all the time. Yes, current age now, current age a little bit later, it's going to be different. And it's not automatically smart enough to recalculate. And it turns out we could do it with the event, but it would be a pain. It's not elegant. It's not transparent. It's confusing. And it probably wouldn't cause a revolt in the room, but it might cause displeasure. So I took the route of minimizing displeasure. And I may have been unsuccessful. How did I undertake that route? Okay, what I did is, ladies and gentlemen, I added a mortality state chart. And this represents that someone can be alive or dead. When they're dead, they're removed from the population, just like that event before. But when they're alive, they're subject to a hazard rate of dying. That's why you see this sort of hazard rate. It says, just like we saw for initiation, there was a hazard rate. This is a hazard rate. There's a chance per unit time. It's a density, probability density of dying over the next year. Okay, an annualized probability density of dying. Okay, ladies and gentlemen, while they're alive here, they have this chance of dying. And this chance of dying is decomposed into two components. One that describes how it changes with age, a kind of baseline, how it changes with age. And then in kind of a Cox proportional hazard type setup, we multiply that by a ratio that's dependent on their current smoking status. Okay? We could imagine a similar thing where we multiply the hazard by another ratio associated with their sex, for example. So maybe women are associated with somewhat lower mortality rates if you control for smoking and age. And maybe we would have a multiplier, a hazard rate ratio for sex we could have as well. That'll be very readily done. It'll be done in a few minutes. The point is, when they change states here, we change their hazard rate ratio. This is something that affects basically how much bigger is their hazard, given that they're in this smoking state, this given smoking state, how much higher is their hazard rate ratio than the baseline hazard rate. In other words, here it's 4 times higher. Their annual chance of dying, you could think of it, probably density of dying, or so daily chance of dying is 4 times higher than it would be if they were a never smoker of the same age. Do you see that? Here, their chance of dying is twice as high as it would be of a smoker of the same age. Here, for never smoker, their chance of dying on a per day basis is the reference value. So we parceled out in kind of a proportional hazards way the risk of dying into 2 components. One is an age-based component, one a behavioral component associated with this behavioral risk factor of smoking. We then divided them up into an alive category, and we had this applied. So here we look up their rate as a function of age. See that? And then we multiplied whatever that rate is by this ratio that applies for their current status. Does that make sense? Okay, I sense muted agreement, perhaps muted resignation, but I don't sense open revolt.
Can you go back to the transition for a second?
You bet. This guy here. Okay, yes. There we are. Here, we could zoom in on it. Yeah. So here we're looking up, for my age, what's my hazard rate? And then I'm multiplying it by this multiplier, this hazard rate ratio, for my behavioral risk factor status, the fact that I'm a smoker. So when I'm a smoker, I have 4 times the rate for my age. When I'm a former smoker, I have 2 times the rate for my age, a baseline rate. When I'm a never smoker, I exhibit the baseline level of mortality by age. Does that make sense? So we've decomposed this into these pieces. Who would like me to explain more? Okay, ladies and gentlemen, shall we run this model?
One question.
Yes.
What happens when the person relapses smoking? Is the rate changing at the same
It
time?
is. Yep. When they've come back into smoking, as soon as they enter the smoking status, their rate changes again, back to the smoking rate. Yeah, to the level of smoking. Incidentally, this leaves open the possibility of extending this further. We could have the rate further be multiplied by a hazard rate ratio based on their cumulative history of smoking. How many pack years they smoke. How long have they been smoking? What sort of types of smoking? Are they using, are they a cigarette smoker or a smoker associated with cigars or something along those lines? Cigarillos, blunts. So ladies and gentlemen, here we have a situation where there's differential mortality. Those who are individuals as they get older, regardless of their smoking status, they exhibit a different, okay, now this is still a distressingly older population. Okay, so my hypothesis is our mortality rates are just too low. Let me check that hypothesis. There's a very easy way I could check that hypothesis, and with your leave, I will do so. I will do it like this. I'm going to take whatever mortality this is, and I'm going to multiply it by a factor of 4.0 times this. And I want to see what the resulting distribution is like for age, to see if it is a more comfortable one. Here we go. Okay, there's still some older folks here. Okay, okay, another thing I could have done, you notice I cap, that doesn't make sense.
That 100 should be 0.
That 100 should be 0.
Oh, line.
But it should be, I mean, even if it's 0.4, they should last on average 2.5 years after that. And they are here, exhibiting a mortality by year. This is going on every month. This is being recalculated. So here we are exhibiting a mortality profile that in my mind is too small. Okay, so once again, I'm stuck in a debugging situation here. Yes. Okay. So I hereby declare a break. And I don't know what you folks are going to do. I'm going to debug this. Okay. Okay. So I will look forward to briefing you on this.